Hello, geometry students. So, we are doing the group practice right now. I'm looking at this problem. It says we're working on reflections. Now, what I have here today, here and here, are guitar picks. It's very hard to pick similar items. I wanted to find two similar items, and I looked at them. I said, well, these are exactly the same size and shape, right? The only difference about them is color. So these are technically congruent from a two-dimensional standpoint. So I have two identical things. The only difference is the color. I picked two different colors so we could imagine something here. So as I'm working here, so now I also have a purple marker to go with the purple guitar pick and a green marker to go with the green guitar pick. Okay. So now, let's imagine for a second you were a guitar pick. You were this purple guitar pick. Let's imagine the y-axis here. Y-axis here is a mirror. We're going to say, well, what if this was a mirror? Now imagine for a second if you want to get up and go into your bathroom and look at yourself in the mirror. When you walk up to a mirror, so I'm walking up to my mirror here, and there's a guy, for me, for the ladies, there's a girl on the other side of the mirror looking back at you. Now this person in the mirror looks almost exactly like you, but they're opposite. Their left-hand side is your right-hand side. Your right-hand side is their left-hand side. If you notice, these two picks have turtles on them. Okay? The thing is, guitar picks used to be made out of turtle shell, but they don't do that anymore because it's bad for turtles. But, so they still have pictures of turtles. I guess they say this feels like a turtle shell. It's a synthetic turtle shell. Okay, so here you'll notice the turtle's head is pointing down, and here the turtle's head is pointing up. So they are reversed like that. So you're looking into the mirror. There's a reflection of you looking back at you. Now, if you took steps closer to the mirror, your reflection would do exactly the same. And if you went all the way up and put your nose on the mirror, the guy in the mirror or the lady in the mirror would put their nose on the mirror. And you said, oh man, you can see all my zits. And so you back up a little bit. And he or she would back up. Then you move back further. And further and further. But you're always, the person in the mirror is the same distance from the person looking into the mirror. So this imaginary person, who is really just your reflection, is always the same distance away from this imaginary wall between you. If you thought of it like a window and you were looking at someone else, that is what would happen. The closer you get, the closer the person in the mirror would get. And the further away the person in the mirror would get. And we can measure this distance on a piece of graph paper because we have these little boxes here. We can count them. So, since purple is our original, and green is our new person, or the imagined person, I'm going to make this problem this. Okay, first thing this says here, which is very, very interesting, what is the image of 3, 4? Okay, well, let's find 3, 4. It's our original image. It's going to be 4. It's going to be our pre-image. 1, 2, 3 in the x direction, right? And 1, 2, 3, 4 in the y. So here's 3, 4. Now, sometimes they will say reflected across the x-axis or the y-axis. So it's important to know what your mirror is. You have to find your mirror. And your mirror is x equals -1. So where does x equal -1? Let's make this red. X equals -1 right here. But x is also -1 right here, right here, right here, right here, all the way up and down. So x equals -1 is really just a vertical line where x in all these dots is -1. So there's my mirror. Now getting back to the thought. Well, how far is this point from the mirror? Well, let's count. I'm not going to use the red marker. I'm going to use my purple marker, of course. I count 1, 2, 3, 4. So this person standing here is 4 blocks away from the mirror. So where is the green one? Well, we said they're the same distance from the mirror. The image, which is what you're looking at, is the same distance from the mirror. So if it's got to be 1, 2, 3, 4. And there's my new P. So if this was, I'll do the correct naming. We call this P. This would be what we would call P prime. That's it. So they probably also ask us to put in the number, which we're going to do on the quiz when we take the quiz. So what is this number? We'll have to give the x comma y value. X is -1, -2, -3, -4, -5, comma, and I go up 1, 2, 3, 4. So, what is the image of P34 reflected across the line x equals -1? Always, always look for your mirror, okay? And then use the mirror to decide where the other one is. All right, I'll be back in a minute with a little bit harder one.